So let's discuss whether y prime minus y squared equals 0 can be solved by y equals 1 over x. So let's appreciate this. First of all, notice it says y prime. So what do we have to do first? First, we have to differentiate this. So just go through that process. Differentiate the potential solution. First of all, I would write it as x to the negative first, and then use the power rule. So negative 1 down, x to the 1 minus 1, negative 1 minus 1. That then gives you negative x raised to the negative second, which is the same as negative 1 over x squared this way. So that's the derivative of the potential solution. So plug it in and see what you get as a result. Let me just kind of move this over here. So supposedly we should have the left side equal to 0. So we should have, in other words, negative 1 over x squared plus the square of the potential solution, so 1 over x, like this. And we're asking, does this equal to 0 or not? Now at this step you have to be very careful right here, because you have 1 over x squared negative, and then this is 1 over x, and this is squared also here. Notice that in this plug-in here step, x cannot be equal to 0 because we do not divide by 0. So like what you see on the screen is valid except if you try this right here, okay? This negative 1 over 0 squared plus 1 over 0 squared. This is not valid when x, right, is 0 in other words. Then it's not okay. So then when you do this, you have to assume that x does not have the value 0 essentially as you're doing this. So you're going to have negative 1 over x squared plus 1 over x squared, distribute the 2, and then we're asking, does this equal to 0? Sure. The terms on the left are identical, so you subtract them. That means you really will get 0 equal to 0. That's true. But again, let me stress, except when x has the value 0, then it's not true. Another way to think about it that might be helpful if you're a visual learner, what is this saying? Well, it's saying the following here. Take the negative 1 over x squared, the first derivative, add to it the original function, which is 1 over x squared. And when you add them, supposedly the sum of the two is equal to 0. Well, that is true. Look, it doesn't look like much has happened here in the graph, but it has. In other words, we have a graph right here. See, this is equal to 0. It's that line going across. And it's true. That's all very true except right here. Except as 0 itself, it's not true. Another perspective on it, if you're a visual learner, that might be somewhat interesting, is this one right here. Look carefully, for example. If you don't do this instead. Graph each piece independently. Graph negative 1 over x squared, which is the first derivative. Okay. Graph the second piece independently. 1 over x squared, which is what you get from 1 over x after you square it. And if you look at it very carefully, look at it. As you go across here, what do you see? Well, for example, at x equals 1. This is negative 1, this is positive 1. When you add them, you get 0, right? Whatever this y coordinate is, when you add to it that y coordinate is 0 because they're opposite sign. Negative 1 plus positive 1 is 0. It's like that everywhere except at the origin, because 1 over x squared and the negative 1 over x squared, they blow up at the origin. They have infinite discontinuities. So adding them at the origin doesn't make any sense. That's why you have to say that 1 over x is a valid solution except at x equals 0. I'll leave it at that. So if it's been helpful or interesting, insightful, whatever, leave a like.